All right, it's time to kick off our second data modeling example, and this one is more complex. We're going to add some complexity as we move on here. This is going to be an e-commerce store. So again, let's walk through that same process we did in the last one. Understand the under application, know what you're building, then go on and build your ERD, your entity relationship diagram, to know what objects you have and how they relate to each other. Then define out all your access patterns and put them out in a list so you can methodically walk through them. And then finally, once you've done all that prep work, then you can get into designing your primary keys and your secondary indexes to handle those access patterns. So let's dive in and understand what we're building here. We're going to be building an e-commerce store. We're not going to handle all of it like inventory and shipping and all that sort of stuff. We're just going to handle sort of the ordering portion, customer management, order management type stuff. So let's walk through a couple example screens. This is some from Thrift Books, which I think is going to be pretty similar, but imagine you build something like this. When a user goes to their profile, the customer profile, this is what they'd see. They'd see some information about themselves, as well as the most recent orders they have in their application. When you look at those orders, notice that it doesn't have all the information about the order on this page. It just has some overall summary information like the order number, the number of items, the status, the total price. If you want to click into one of those order numbers, that's when you can get details about the orders, including the different items that were purchased, the payment that was on it, things like that. So that's where you can really drill in and get some details about that order. Additionally, there's also a section where you can save addresses. We have that here. We might want to save addresses just to make it easier for checkout later on. So here I have a couple saved addresses. I've blocked out the actual identifying information, but the first one is named home. The second one is parents' house. So I have a couple different named addresses just to make checkout easier for me going forward. So just a quick summary of what we're building. Again, an e-commerce store. I'd say there's two big areas of it. There's customers and their addresses, and there's also orders and order items. And then, those are linked between customers and orders as well. So now that we understand our application, let's build that entity relationship diagram, that ERD. A little more complex than the last chapter, but still pretty manageable. So we have 4 different entities here. Starting in that top left, we have that customer entity, and a customer has a one-to-many relationship with addresses. So the address is going to belong to a specific customer, but a customer can have multiple addresses. Also across the top, a customer can make multiple orders. So you see that order entity in the top right. That order is going to belong to a specific customer, but a customer can make many orders over time. Then finally, going down that right-hand side, an order is going to be made up of multiple order items because I can buy different books or whatever it is my store sells in one order. So an order item is going to belong to a specific order, but an order can have multiple order items. So again, let's just look at that. 4 entities: customers, addresses, orders, order items, and 3 relationship: customers to addresses, which is one-to-many, customers to orders, which is one-to-many, and orders to order items, which is one-to-many. I also want to get out that entity chart, that entity diagram. Again, all we're going to do is start with our entities down the side there: customers, address, order, and order items. And then we just have PK and SK, very generic key names that we'll use here, assuming that we're going to be using a composite primary key because we have some fetch many access patterns. Speaking of access patterns, let's drill into those access patterns and see what we have here. We have a bunch of them here. First of all, we just want to create a customer. So when that new customer comes, we need to let them sign up, enter their username, their name, their email address, things like that. The big key here, and our PM is insistent on this, we want to have it be unique on both username and email address. So it makes sense. You don't want to have 2 customers with the same username, but we also want to make sure that a customer doesn't sign up for multiple accounts with the same email address. We're worried that could confuse them. So we're going to have that limit here. So that's an interesting requirement. Finally, we have the different CRUD operations on particular addresses for a customer. So a user can create that new address. They can update an address, a particular named address. If your home address changes or your work address, you can do that. You can also delete an address if you want to. If you no longer ship to a particular home or your parents' house or something like that, you can delete that address. Next access pattern we have is to create an order. So when a user comes in, they actually want to place an order. They've got some items in their basket. They submit that. They're going to submit all the items they want to purchase, and we're going to save that for them. Finally, the next access pattern we have is update order. So as that order is moving through our system, particularly the status is going to change. So it's going to start out in that placed status, but then we're going to get it ready for shipment, and then it's going to be shipped, and then it's going to be delivered, or perhaps somewhere along the line it got canceled. So want to make sure we can update that status. Finally, on that customer overview page, we saw that order history where we want to fetch the customer and the most recent orders for that customer. So we want to handle that access pattern. And then if a customer drills into one of those orders, clicks on an order, they can get more details about that order by viewing the order and the order item. So see all the different books or whatever it was they purchased in that particular order. All right, so we know our application, we've designed our ERD, we know our access patterns. It's time to get in, model that table, design our primary key and our indexes to handle those access patterns. As we start off, first thing we always need to think about, do we want to use a simple or composite primary key? Again, I say you're almost always going to use a composite primary key, and that's the case here. We have multiple different types of entities we're going to be putting into our table. We also have a couple different fetch many-like access patterns, so we're going to do a composite primary key here. And thinking about what entity to start with, what sort of interesting requirements do we have? I think two main categories. Number one, a customer needs to be unique on two different attributes, the username and the email address. So that's a kind of an interesting requirement. Usually it's just on one attribute, so we'll see how to handle that. The second big interesting requirement we have is handling these join-like patterns. We have a couple different join-like patterns where we want to fetch a customer and the addresses. That's a join, right? Because you have a one-to-many relationship and you want to get both parts of it. We also have fetching a customer and the customer's orders and fetching an order and the order items. So we'll show how to model those in this chapter. So I'm going to get started modeling the customer entity. You usually want to start with something that's pretty core to your application, and I think this is a good example. You could go with either customers or orders, but because customer are the parent entity to orders, there's a one-to-many relationship between customers and orders. It's usually better to start with a more parent entity in your application. So let's start there. Again, two big things we need to think about with that customer entity. Number one, it's unique on two different attributes, the username and the email address, as we've discussed. And then second, it's the parent of two different relationships, addresses and orders. So we're probably going to be having to use that primary key, use that composite primary key to handle some of those patterns. So first of all, let's think about that uniqueness requirement, and this is how we're going to handle it. When you have a uniqueness requirement, you basically need to have an item that's solely dedicated to that uniqueness requirement. And that means if you have uniqueness requirements on two attributes, you need to have two different items to represent that. So let's see what that looks like in our table. Here we've got two customers in our table, but you can see that there are 4 items. But basically what we have for each customer is an item that tracks the actual customer based on the username, and then also that tracks the customer email. So outlined in red here, I have the items for Alex Debris. That top one is the actual customer item. That's using the username in that primary key. The second one is that customer email address that includes that customer email in that primary key so that we can track uniqueness on that. So let's see what this looks like in code. And since this is the first time we're getting into a more involved example, I want to show you how I like to structure my code. What I like to do is I like to have 3 different directories, one for data, one for entities, and one for handlers. And the entities holds sort of the representation of our different objects and also some information about how we serialize that to a DynamoDB item, how we generate the key for that item, and also how do we deserialize an item from DynamoDB into our actual object. So when we look at that here, let's look at the customers in the entity thing. I have this class called customer that has, the constructor that has the different properties we need there. It's got a key method that generates the primary key for my item. It also has a toItem method, which is going to turn that that customer object into a DynamoDB item. So it not only has the key, but it also has this type property that says it's a customer, and also the different attributes with all the DynamoDB attribute types and all that for me. So I don't really need to think about that later on in my code. Another thing I have here, if you scroll down, I have this customer email object here. Because remember, we have both a customer and a customer email. That's going to take the email and the username. Again, it's going to have that key method. It's going to have this toItem method that handles all that work. Now, if I close up the entities, then I also have my handlers. This is where I'm actually handling my different HTTP methods that I have for these. Again, I've got this JSON schema that defines what needs to come in. So in this payload body, I'm going to have a username, I'm going to have the email, and I'm going to have the name. And these are all required when you're creating a customer. Once that happens, I'm going to initialize this customer object and pass it to this create customer function that is coming from my data directory. So now let's go check out the last part, which is our data directory. Again, I have a method that's named after exactly what it's doing, create customer. So let's see what this is doing here. Here I have this create customer function. In there, it's also creating this customer email object as well, which is not really relevant to my application itself. So that's why I'm sort of hiding it in my data here. But it's relevant to DynamoDB because it's how I track uniqueness here. So I already have that customer object. I also create this customer email object. And then what I do is I create these, I'm going to do a transact write item where I'm doing a put for that customer. And I'm just saying, hey, the item is going to be this customer, and using this toItem method to, serialize it into that object or that item that for DynamoDB. I'm going to use that table name. And I'm going to have this condition expression that says, hey, make sure that this, there's not a customer with this particular primary key. So I'm going to use this attribute not exist to assert that that's the case. I'm going to do the exact same thing with the customer email, serialize it to an item and assert that it does not exist. And what this is doing is saying create both of those items. Because I'm wrapping it in a transaction, it's going to help make sure that if either one of those does exist, if there's a customer with that username or if there's a customer with that email, one of those will reject, and it'll reject the entire transaction. So I handle that. If it works, then I just return the customer. If I get an error, then I look at the error message that I get back. And then based on that error message, I give it a more specific result. So here, if the what's going to happen is it's going to give me a cancellation reason for each of those transact write item requests that I put in there. So if that first one in there is, a condition check failed, that means my first request right here, putting in this customer, that failed. So then I can say, hey, a customer with this username already exists. If that didn't have an error, but the second one, the second item in our request failed, and that means that customer email item rejected. So then I can say, hey, a customer with this email already exists, and I return that to my user, and then that's what it's going to show to that user when it makes that request. All right, so let's give this a shot by making an actual request. You can see here I've got my base URL with the /customers route. I'm making a post request there. I've got my payload body where I've got a username of Alex Debris, an email address, and a name. So if I send this up here, let's see what we get back. If we look at our result, you can see that it returned the customer for us, and this customer has the username, email, name, just like we sent in there. And now if we make this request again, let's try that again with the same parameters. Oh, now we get a customer with this username already exists. So now we're ensuring that if someone tries to create that customer with the same username, it's going to fail. Let's just try that. Maybe let's try a different username, but let's try a new email address or the same email address. And now we get an error that a customer with this email already exists. So it's doing that again. Let's just change that up just to finalize it off. So now we've got a different username, a different email. Let's send that up. And then it actually did create that customer. So you can see as part of that customer creation flow, that transaction is handling a uniqueness on both that username and the email that's sent up for us. Likewise, we can check the get customer here. This is going to be a get request on that customer /Alex Debris. Let's give that a shot. And then what we're able to do is fetch that customer, and we can also fetch that other customer we created as well, Alex Debris 12. You can see it's got Alex Debris 12. It's got that different email address as well. So now we've got that post, we've got that get customer implemented. So let's go start to fill in our entity chart here. And now we've actually added an entity here. We have customer email, which wasn't in our ERD, but we need it, again, just to track uniqueness on that email item. So now we have two entities here. We have that customer whose PK is going to be customer hash and then the username, same with the SK. And then we have that customer email entity whose PK is going to be customer email hash and then that email address, same with the SK to handle that uniqueness. Let's move on there and handle our first one-to-many relationship we have here, which is customer addresses. So if we go back to that ERD, we have, customers and addresses there on the left side, and there's a one-to-many relationship between them. And we need to think about how to handle that. And if you go back to our actual pattern, you can see it. Here's where the addresses will be listed here. And one thing to note here is addresses are only going to be retrieved in the context of a particular user. So we don't have any access patterns that operate directly on that access pattern where we need to find that outside the context of a user. So we don't have a get user by address endpoint or anything like that. Given that, and also given that we can reasonably limit the number of addresses we want people to save, maybe we just say, hey, you can save 10 or 20 addresses. Given that, we can use that first one-to-many relationship strategy that we talked about way back in the one-to-many relationship strategy chapter, where we denormalize by using a complex attribute on our parent object. So let's see what that looks like in our table. Here are our customer items again, and all we've done here is added this addresses attribute that is a map, and it includes the different addresses we have. So you can see there, Alex Debris. It's kind of tough to read, but basically it has two addresses, a home and a business, and then also Vito Corleone has his home address as well. So let's see how we'd handle that in our code. Let's first start in our entities file. This is our customer entities file, and what I have here is I have another class called address, and this is just going to be a sub property on a customer, a sub attribute there. So it doesn't turn into a DynamoDB item itself. So it doesn't have a to item property or even a key method on it. Instead, it has a to map, which knows how to represent that address as a map in DynamoDB. So what it's going to do is add those types and serialize that, the street address, postal code, and country all into formats that DynamoDB will like there. Additionally, when I'm creating that customer, I'm adding this addresses thing on it and setting it. And then when I'm serializing it to an item, I'm creating it as a map and using this format addresses property on there so that I can, what it's going to do is take those different addresses and format those in a way that's DynamoDB friendly. And the nice part about this is I don't have to worry about that now in my more data access code. It's more just handled for me. All this serialization and deserialization is handled there. Speaking of deserialization, this parse addresses thing, when I'm creating a customer from a DynamoDB item, which I'm doing here, I'm using this parse addresses on that addresses attribute to know how to deserialize that from our DynamoDB map into something useful. So now let's go into the handler for that. If I'm editing an address for a customer, and this could be adding a new address or editing an existing address. In my JSON schema, in that body, I'm saying, hey, you got to send up what the name of this address is going to be. Is it home, work, parents' address, whatever, and then include the street address, postal code, country, all that. As part of the path parameter, I'm going to have my username because we're just going to include that in the path route. And then what I'm doing is just creating that customer object, but also creating this address object as part of that. And I'm going to call this edit address for customer data method. So if I go into that, I get that here. And what I'm doing is I'm going to be calling an update item on DynamoDB. So instead of going out and fetching that customer, manipulating the address object, and then reinserting that customer object, I can just do an update in place, which is really nice. And so what I need to do is I need to specify the key of the item that I'm updating, which is going to be that customer. I also want to specify this condition expression to make sure that this attribute exists, to make sure that customer is already present there, because I don't want to set an address for a customer that doesn't exist. So I'm going to make sure that happens. And then I'm going to use this update expression. In this particular one, we're actually updating a nested property of a map in DynamoDB. So what I'm doing is I'm saying set this addresses, which is the map attribute, and then I'm using a dot to access a particular address within that map, the name attribute, and setting it to this address. So I'm setting it to the name that's given me. So if you put in, this is called my home address, this is going to set addresses and the home key in that address to this particular value. And then in this expression attribute value, I'm just, again, serializing that address to a map. The last thing I'm doing is saying, hey, return all the new attributes from this particular request, and then I can return that customer from the item, and I'll have that fully hydrated customer that I could return there. Again, catching errors there. I have a very generic message, but if we get a more specific error condition, like this condition check failed exception, which means this customer does not exist, then we want to return a more specific error message, and we'll do that to the user. All right, again, let's handle these with some actual requests to make sure this code actually works. So here we have this edit address for customer route here. It's going to be on the /customers, then the customer username, and then the addresses path. I'm doing a post request there. And again, here's that payload body that I mentioned I was going to put. Let's try setting that up and see what happens. You can see it returned a 200 OK, and now we have our full customer object that has this addresses, this named work address, and the different properties for that address. So now if we go to our get customer, we did this one before, but let's take a look at what that looks like. Now it has all those attributes on there. Likewise, if we want to do delete, we can do this here. The path is going to be pretty similar, but what we're going to have is we're going to add a parameter at the end to say which named address do you want to delete. We have this, we're going to use the delete method, and we'll send this up. And the code for this is actually very, very similar to just adding an address, so I didn't do it, but instead of doing a set address, you're just going to do a remove in your update expression. After that comes back, you see I don't have any addresses left here anymore. If I go back to that get customer and fire that off again, you can see I get that customer back, but again, there are no addresses associated with it. So let's wrap up this address entity here and go back to our entity chart. The great thing here is that address isn't a separate entity. It's just attached to that customer entity that we already have. So there's not a PK and SK pattern here. Whenever we go fetch that customer object, it's going to return all the addresses with it, which is great. Let's move on to the next entity we want to handle, which is orders. Again, if we look at our ERD, we see there's a one-to-many relationship between customers and orders. So a customer can make multiple orders as they go. This is what that page looks like. If you go to your profile, you're going to see that order history. There's the orders there. But again, the order just has some metadata about the order on this page. It has the date, it has the order number, the number of items, the status, the price, but it doesn't have each individual item in it. If you want to do that, you drill into a different page, which will make a separate request. Given that, this is how we're going to model out our order item. You can see I still have my customers in here, but I've also added some order items. There are 2 of them outlined in red here. The great part about this is that the customer and the order items have the same partition key. They're both using that customer hash username partition key, so they're in the same item collection. That's going to help with some of the access patterns we want to do here. Let's check that out. As we check out this order item, I'm not going to walk through everything like I did with the customer and the addresses because a lot of it's pretty similar, but I do want to point out a couple things. First of all, in our entity thing, one thing we're going to have for each orders, we're going to create an order ID, which is just going to be a random ID, but we also want some sorting because we're going to want chronological sorting with orders. We want to fetch the most recent orders. So what we're going to do is use the KSU ID for that. We talked about that in an earlier chapter on sorting, so go check that out. But basically, we just have this generate order ID method based on the created at timestamp that's going to be passed in, and it's going to create a KSU ID that'll guarantee some uniqueness while also giving us chronological sorting. A second thing that's interesting here is that we're going to be passing in items into this constructor. And when we go down here, if in our constructor, if that items, if there are items in that array, we're going to create these new order items, which we'll talk about modeling in a second. But the reason we need to do that is because we have some summary info on that order about those order items, like the number of items in that order or the total amount of that order, if all those prices are summed up. So that's one thing that's kind of interesting here. I want to look at the get orders for customers method because this is interesting and new as well. So what we're going to do here, when we want to get orders for a particular customer, we want to get both the customer and all the orders. So this is kind of like a join operation where we're going to be returning 2 types of results. So let's check that out. First of all, the username will be in the path parameter. That's how we'll get that. So we'll create a customer object from that with just the username. You'll notice it doesn't have some other properties like the email or the name because we're not going to be creating a user here. We're just going to be using it to read. So we'll see what that looks like. And then we're going to call this get orders for customer. Let's go to our data module here and check that out. So here's our get orders for customer. We pass that customer in. We're going to be running a query operation because we want to fetch many. And what we're doing here, our key condition expression is saying, hey, give us all the items where PK equals this particular PK. And what we're doing is that PK key from the customer itself. So then we're getting all the items that live in that particular item collection. And remember, the customer and the customer's orders all share the same partition key in the same item collection. So that's what we're fetching here. So we wait for that. If we don't get anything back, we say, hey, the customer doesn't even exist because we didn't even get that item. Otherwise, what we're going to do, we're going to get that customer item, which is going to be the first one in our result, and we'll create a customer object from that item. And that's what we have here. And then also for every other item that was returned, we know that's an order item. So we're just going to map over those and create an order from that item. So then we've got an array of orders here. And that's what we'll return to the client. So this is pretty interesting because it's showing us how to get different types of items, how to deserialize those from DynamoDB items into application objects and return those. So let's check that out with some requests just to make sure this works. So here's my create order endpoint. I didn't show how this works, but it's pretty similar to the create user endpoint. So you're just gonna have to trust me. Look at the code if you want more on that one, but it's using /customers, then the username, then orders. And this payload has, it has the address used, so the specific address used, and then an array of items. So this one just has one item in it. And if I send that up, it's gonna create this order. Let's see if it worked. It's in there. It's got some information about the order, including the username, the order ID, addresses created at, the status of it, the total amount, number of items, all that stuff, all the summary information about that particular order. I can place another one right now. This is going to be the exact same. Actually, let's just change something just to get us a little diversity there so we can see this. So let's send up a second order that we made shortly after. This one has Air Force 2s and it has a different price on it. And then if we go to that get orders for customer endpoint, this is the one that we just showed and walked through that's going to use that query and it's going to get the customer and the customer's orders. Let's take a look at what that looks like. Again, remember we've submitted 2 orders here, so hopefully it's going to return both of those for us. And here we go. We've got our customer item. So we've got that, which is useful to us, and then we've also got orders, which has 2 different orders in it, which is great. So here's our first order. This is the most recent order. This is the one that was $16.99. Remember those Air Force 2s? They cost a little bit more. But then we also have our original order for the Air Force 1s. This one's only $15.99. You'll notice here that this doesn't include all that information about the order items, right? Because we're just handling that sort of order overview page where it has the different orders, it has meta information about those orders, but it doesn't drill into the items of that one. All right, so let's go back to our entity chart here. We now have our order item in there. The PK is going to be customer hash and username so that it puts it in the same item collection as our customer. And then SK is going to be order hash order ID, which is going to give us that sorting and that chronological ordering within that particular item collection. Let's move on to the last entity we need to model out here. This is the order items. Again, if we look at our ERD, we see in the bottom right, we have that order items, and orders have a one-to-many relationship with order items because an order can have multiple order items, but an order item belongs specifically to one table or to one order. Now, let's remember where we actually access these order items, and it's in that sort of order detail page. When you're drilling into a particular order, then you're showing it. So we don't want to put these order items in that same item collection as our customer and orders because it's really going to slow up that access pattern. Because now when we fetch a customer and the customer orders, it's also going to fetch all those order items with it and make it really slow. So we're going to do something else here. This is what we're going to do. Look at our table here. We've added in some order items outlined in red there on the bottom. They're each in their own partition, so sort of just on their own. A second thing we're going to do is add these GSI1 PK and GSI1 SK values, and we're going to have those on our order items and, our order DynamoDB items, and then our order item DynamoDB items. This is confusing terminology there, but those will each have those properties there, and then we'll make that secondary index. When we reorder that, then it's going to look like this, where a particular order is going to have its own partition, its own item collection that has both the order item in it and then also the order items in them as well. Let's take a look at the code to handle this, and this is going to be pretty similar to our last access pattern, the get customer and the customer's orders. The one difference I'm going to say here's this get order pattern. We're going to pass in this order object. We're going to be making sure that when we query, we pass in that index name because we're not querying the base table anymore. We're actually querying a secondary index. Again, change those key conditions accordingly to be GSI1 PK and GSI1 SK rather than just PK and SK. But other than that, it's going to be very similar. We're going to get a couple different items back. We're going to look for that order item first and create the order from that item. And then we're going to have all our different order items and return that. Let's see what that looks like when we make the request. So again, I have this create order. This time I'm going to put a couple items in there just to see what it's like. So we've got the Air Force One again, but also someone, of course, wants to buy the DynamoDB book. We'll send off that request and make sure that that order went through successfully. Looks like it did. We have this order ID now, so let's copy that. And now let's pop over to our get order method here. And what that's going to get to, it's going to go to customers, the customer username, orders, and then the order ID, which we just pasted in there. Let's send that up and hopefully it returns it. And there we go. We get our order, which includes all our order summary items, including the number of items, the total amount paid. But in addition to that, we also get all the different items in our order. So that's going to serve that order detail page that we talked about. All right, so let's finalize our entity chart here. We've now added that order items entity at the bottom there that has that PK and SK. They're going to be in their own partition on that base table. But now we also need to make sure we have our entity chart updated for this global secondary index we have. So let's do our GSI1 PK and GSI1 SK. You can see customer email address. None of those are in that GSI1, but the order and the order items are. So you can see that they've got those filled out there. All right, so we made it. This example was a lot more complicated than the last one, but we just sort of worked the process and managed to get through it. Let's review what we did here. First of all, our table has a composite primary key using very generic names like PK and SK, and we're going to overload that primary key to mean different things for different items. We also have a secondary index, GSI1, that has attribute names of GSI1 PK and GSI1 SK. Again, very similar generic names. If we look at our entity chart here, this is what we have. We have that customer entity and the PK and SK there, making sure that username is unique. We also have that tracking item, customer email, that's making sure that no one uses the same email across multiple users in our application. Finally, we identified address in our ERD, but we actually aren't modeling that in DynamoDB as a separate entity. That's just going to be a complex attribute on that customer item. Finally, we have our order and our order items. If you look at the entity chart for our GSI1, customer email address not in there, but order and order items are in there to give us that order detail drill-in view where we can fetch an order and all the order items for that order. Let's walk through our access patterns here. First one we have up top is that create customer. That's going to go against our main table like all the rights usually are. Big parameters you're going to have there is going to be the username and the email address. And the note there is you're going to be writing two different items in that single transaction to assert uniqueness. So we have that customer item, but we also have that customer email item just to make sure we have uniqueness on that email. Second big set of access patterns we have are around create, update, delete, address. Again, that's going to happen on the main table. Parameters there are going to be the username, but also the address name. And remember how we're doing that. We're updating that map attribute directly rather than fetching that user, pulling it down, manipulating it, and putting it back. We're just going to do an update item directly on a nested attribute in that map. Next access pattern we're going to have there is a create order. This is going to be on that main table. Parameters you're going to pass in is going to be the username to be used in that primary key. You also generate an order ID on the back end, which is going to be a KSU ID. And what it's doing there is it's creating the order and the order items in a transaction to make sure that's all saved successfully. Next access pattern, we didn't cover it much, but update order, it's going to be very similar to that update address where you might need to update the status of the order as it goes from placed to shipped to delivered or canceled, anything like that. So the parameters you're going to need there is going to be the username and that order ID, and you can update the status on that order. Finally, we've got a couple read-based patterns. We have view customer and most recent orders. That's going to happen on our main table. We're going to use that query operation and use that username to find that customer partition, find that customer item, but also the order items for that customer. Finally, that last access pattern we have is another type of join operation. We're viewing the order and all the order items. This one is where we need to go to that secondary index, that GSI1. We'll use that order ID parameter and use the query operation to fetch the order and the order items, return those all in one request. So a lot more complicated access patterns here. We're doing pre-joining, we're doing updates, we're doing lots of interesting things there. This was a lot of fun. Next one gets even better. We're going to be building a deals website. We have some sparse indexes, we have some DynamoDB streams, we have some pretty complicated access patterns. So check that one out.